All right, so I guess we can get started. My name is Lana Kalashnyk. Thank you so much for having me today. I am based in beautiful Brooklyn, New York, so it's kind of loud right now on the streets. So I appreciate you dialing in on a Saturday morning or afternoon, whichever time zone you're in. So today I really wanted to cover a few topics on building blockchain applications with Truffle on AWS. I've been doing this for quite some time, so I've been acting as a principal blockchain architect for about 3.5 years. Been working on blockchain for much longer, and essentially my job is to build the right solutions from ISV and consulting partners perspective to make sure that whenever somebody comes to AWS, they have all the right tools to do the job. So today I wanted to share some of the tools that we've built over the past few years, and also some of my takeaways on how I'm seeing customers using blockchain tools, Truffle, and building applications on AWS. So just to set the stage, I wanted to look a little bit more broadly. So I think we do have a pretty good understanding of the value of decentralization, of public blockchains, and so on. So obviously having control of your bank account, making sure that if you have open source developers working, such as guys at Gitcoin, you can pay them irregardless of the geo they're based in. Lots of interesting applications. But the more we were looking at those applications, the more we were finding some of the parallels in implementations, for example, in supply chains. So here I have a little blurb from Harvard Business Review on supply chain management issues. So you might think this was kind of written by somebody who is trying to sell blockchain to folks, but it actually wasn't. So some of the challenges that supply chains, for example, are facing are pretty similar to other things that we're tackling in public blockchains. So for example, incentives issues. So a lot of companies are facing incentive issues in networks, such as complex networks like supply chains, because of hidden actions by partner firms, hidden information. So here you have data or knowledge that only some of the participants possess, and badly designed incentives. So here are some solutions that this guide was offering again 10 years ago. Is number one, acknowledge that the problem exists. Folks love to say that if it's not broke, don't fix it. Well, even acknowledging that incentive issues are persistent, that we have these silos, that we're not sharing information, that's half the battle on any production implementation. The second step is diagnose. And here we've seen that
Hey, Lana,
really,
your
yes.
screen is black. I don't know. Okay, keep it minimize reason.
Oh,
And when you put
okay.
presentation mode, for some reason it goes black. I'm not too sure why, unless anyone else recommendations. Everyone can see it now. I want to make sure
Sorry,
catch you
guys.
before we get too far. It's okay.
Yeah, I was already all right. So let's just roll with it. It's gonna be one of those days. All right, so winding back. So this is what I was talking about in Harvard Business Review. So here we're looking at some of the incentive issues that we know exist, and how do we fix it? Well, we fix it by building multi-party computation technologies. So another thing that we're seeing our customers are really focusing on is the pace of global innovation. So the size of data that we have to verify and attest to is growing really, really quickly. So within the next 10 years, it's going to be in zettabytes. So 163 zettabytes to be exact. Also, the continuing pace of technology advances. So we're seeing that if customers are not innovating fast enough, they can be left behind, and also sophisticated security breaches. So all of these factors are really pushing our customers and then our roadmaps into direction of cryptographically verifiable technologies. So now that we're looking closer at some of these issues that our customers are facing, we practice something that's called working backwards approach. So here we're looking at what do multi-party businesses need, and they need to share data. So they need to have an ability to independently verify transactions. They need to have a single pane of view that is shared as shared perception of truth, some call it, between multiple participants, and tamper-proof history of all of the transactions. Currently, approaches for doing that are not exactly the best. They're kind of expensive, frankly. So currently we're using either costly escrow processes or central authorities that are tasked with kind of sharing this information and managing incentives. Obviously, both are pretty expensive. Because of that, we started building some of the ledger and blockchain services at AWS a few years ago. And when we started looking at that deeper, we really tried to find the right tool for the job. So some of the use cases that we were seeing are really falling into ledger category, not really blockchain. So this is some of the use cases where you do need to share data, but you do trust one party to manage it. Because of that, we've launched a service called Amazon QODB. So here I wanted to touch on that one because it is not blockchain. So it has blockchain-like features, but it is absolutely not a blockchain. What it is a journal-first database. Again, whenever we're hearing customers talk to us about building some of the verification technologies with traditional databases, they're not really suited for auditability and verifiability. Typically, if you need to access a log, you have to build that functionality yourself, and there's no way to attest and verify this data. Because of that, we've built in cryptographic verification and hash chaining into the journal portion of QODB. So this way, some customers that don't necessarily need decentralization, but do want some of this cryptographic verification features of blockchains, they can use this database. So pretty cool stuff. The second set of use cases that we're finding is transactions that really do need decentralized trust. So here we're looking at peer-to-peer payments. We're looking at some of the more complex syndicated loan processes, supply chain, specifically cross-border supply chain, where you do have to manage different letters of credit and so on and so forth in retail. So in these cases, there isn't a single authority or even escrow process that could serve those use cases. Because of that, we've launched a service called Amazon Managed Blockchain. So here it supports Hyperledger Fabric and Ethereum. So Ethereum is very soon to come, which is we're really excited about. At the end of presentation, I'll leave some time for questions and also for you to be able to reach out if you're interested in that functionality. The way it works, it's pretty simple. So for right now, for the Hyperledger Fabric implementation, that's probably not super interesting to a lot of you. It's really geared towards enterprise workloads. So here we want to make it really simple to create a network, to add new members to it, and to kind of exit out of it. And here again, our approach is to take away as much as possible of undifferentiated heavy lifting to where customers start focusing on building smart contracts functionalities, enclaves, and so on and so forth. And another cool thing about specifically the way we've architected Amazon Managed Blockchain is that the ownership of the network is decentralized. So let's say, for example, I create a network and create an organization that represents me as a user. As soon as I add another organization to the network, I'm free to leave. So another really cool feature that I wanted to talk to you about today is AWS Nitro Enclaves. So here we're really looking at best practices on the discrete computation. So essentially, we had customers asking for a very long time to bring enclave functionality. So for example, running super sensitive workloads that might deal with PI data, key management, and so on and so forth, where you wouldn't trust to store this data on your typical EC2 instance. And something that made it possible is our Nitro virtualization technology that has been launched a little over a year ago that does provide some of the novel approaches to tackling that. So some of the features for the Nitro Enclaves that we're seeing customers using, and I will kind of bring it home a little bit later on how that fits into overall architecture, is that it does have an independent kernel. It doesn't have any interactive access. It doesn't have any networking or anything else plugged into it to make memory or any of the data readable in the enclaves. It does have SDKs, which is, here's the link that will point you to the repos. And we also built in KMS and ACM management. So essentially, you can store your private keys in your enclave and leverage KMS service to, let's say, sign or verify data. Same thing with AWS certificate management. So you can actually have your TLS terminate at an instance level and store your cert within your enclave. So makes a lot of things a lot cheaper to build, to bring to production. And it also supports cryptographic attestation. So again, attestation works a little bit different than other services. And I'm going to skip over a few slides. So the reason it's different is because the architecture underneath is different. So here we actually build a Nitro add-on. So it's a chipset. So it's a plugin that is a physical device that gets attached to the physical hardware itself. Because of that, we're able to run the attestation service for the enclaves on the Nitro chip itself. So how it works? So it works pretty simply. So the way you would try it out, and I hope you do, is that you would launch an EC2 instance. It does have to have enclave option switched on, and it has to have at least two VPCs, two CPUs as a part of the instance. So what it does is that it builds the same separation. So the Nitro hypervisor builds out the same separation as between EC2 instances to your Nitro enclave. And it's a really powerful concept because typically the way enclaves are implemented in Zen hypervisors and so on is that it's enforced, these enclaves are enforced through encryption. Well, in this case, this is an actual completely separate VM that runs on its own. So as far as I'm concerned, I don't even know, for example, what data or application exist within that enclave. So you would set up an enclave file. So enclave file could be a Docker image or any kind of application that you would want to run with it at enclave. It gets signed with certain hashes generated and populated into the enclave. And the way that's done is through a helper process that is running through the Nitro hypervisor. So here's a good representation of what this instance looks like. So from this perspective, we're not weighing down the EC2 host itself with Nitro hypervisor. So that one is running on this add-on that I've mentioned on the physical hardware device. So again, really great for performance and so on. Your communication is done via vSocket. So there's only one way. So there's only one way to access any data, load data, or extract it from the enclave itself to your instance. And again, this makes the attack parameter much smaller for any applications that you might be running with that enclave. So we're seeing that used for a lot of use cases around tokenization. So tokenization not as far, well, actually you could use it for Ethereum tokenization too, but specifically around credit cards or any kind of sensitive information, you can convert it to a token and use it that way. Storing your cryptographic materials and keys, so storing your private keys in this enclave, and multi-party computation. So if you do have this trusted enclave that you can attest via document, I unfortunately won't have a lot of time to dive into that one. You can do that through this Nitro Enclave technology. Here's a pretty good kind of illustration of what this looks like. So here you have this helper agent that helps you with some of the management tasks of accessing data in the enclave. You have the enclave itself, which is separated just the way an EC2 instance would, and the Nitro hypervisor. I will send some more information after the session for you to be able to look through this information. So now moving on, so we've tackled some of the managed services. We looked at Nitro Enclaves. Now let's look at IDs and CI/CD. So there are currently two ways that we're seeing customers leveraging Truffle, which we love working with. Typically, there are two ways to run Truffle on AWS. So you can run it via a Truffle instance in AWS Marketplace. So here you can launch this free Truffle suite on your EC2 instance and then interact via a CLI, or you can launch it on AWS Cloud9. The cool thing about Cloud9 here is that you can also launch infrastructure from the same terminal as you're writing code. So it's pretty powerful as far as managing AWS specific resources. Again, this is really AWS specific content here. If you wanted to understand how to run this, I've also added a link here where Tim is kind of diving in and showing us how to install all of the Truffle tools and run a simple contract on AWS. So as far as closing this out. So how do we build well-architected solutions? So Andy, our CEO, likes to say that there is no compression algorithm for experience. So by using the same approaches that we've used for other technologies, we are hardening blockchain implementations, and we're actually applying the same well-architected approaches as we do with other institutions or technologies to blockchain. So when we're building out blockchain architectures, it's really important to hit 5 pillars. So we have operational excellence. So this is building the right mechanisms for updates, and making sure that we follow the shared security model. So for example, we take care of all of the isolation, let's say an example of enclaves. So we take care of all of the isolation on the enclave, so on and so forth. However, you as a builder is then responsible to secure the application itself that interacts with these enclaves. Security. So it's really important to make sure that you do have the right separation from any nefarious activity. So here we're really looking at some of the basic things like separating access privileges for your private and public networks, and also leveraging tools like Private Link, which allows you to pass traffic to using our own private backbone instead of the internet. So these are some of the more sensitive workloads. And performance, efficiency, reliability, so having HA built in. Here we're seeing that a lot of customers are using elastic file systems, let's say for failover nodes and so on, and cost optimizations. So let's look at how we can bring down the cost for customers, how we can make sure that blockchain solutions are effective. And this well-architected tool is actually available within console. So if you wanted to run your own audit, you can, and actually inspect where some holes might be. So some of the pretty cool tools that we've built lately. So this is about it for me for right now. Unfortunately, I couldn't figure out the logistics, so missed a few minutes in the beginning, but all of the information covered is available on the slide here. Please don't hesitate to reach out, and I will try to follow up with questions in the chat after the talk. All right, so Amazon Manager Blockchain team also asked me to share this link. If you are working with AMB, I think they're offering some credits and free consultation. I'll share these slides after the talk, so you can ping that team as well. And thank you so much for your time today. I hope you have a great Saturday, and that's it on my end.